So we're going to build a power source, which is going to be a 3.3 volt, very useful for Wi-Fi, radios, and Bluetooth in general. And we're going to learn about perf boards versus PCB, which is a printed circuit board. We're going to learn a few soldering tips, and we're going to learn about hook wire, and two very important options when using hook wire, which is either soldering over or under your board. So let's go ahead and take a look at this project. Alright, so here we are, Perfboard or Protoboard versus printed. This is a printed circuit board, and this is a project that I made a while ago. And this is a perforated, sometimes also called through-hole board. And here we have an example. This has no connections. It's just these header pins connected here mechanically to hold them into place. And this is important because the first thing you want to do is make sure that your components are on there and pretty sturdy before you work on the electrical connections, which are obviously going to be important. So that's the perf board or through-hole board. And this is the printed circuit board. So once you've moved from a prototype like this onto something more permanent, these connections are actually made on the inside of the board. So there are traces, which are wires, which connect the different components. And you can have nice little labels printed on there as well, so that you can just grab your components, line them up, and put them through the holes on the board. And it's just that easy. Alright, now this is for a more advanced topic and for later on in your design life cycle. Let's go ahead and start with these guys, which you can get cheap off the internet. So this is what the original perf board looked like. And what I did was I cut it using just this cutter right here. You make a few runs down one of the hole strips, and then you take this tool right here and you basically just clamp it onto the side and you break it off, just like that. One quick, swift move is better. Okay, you can also cut it with a Dremel, and that's fine as well. Once you're done with cutting it, you always want to file down the edges, which are going to have pieces of metal from the circular pads, and also the fiber, which is something you don't want to get stuck with. And so you file it down edges, sides, and corners, and once you are comfortable, you can go ahead and just run your fingers through it slowly, carefully. Don't want to get anything stuck in your fingers, and that's it. But this is the piece that we're going to be working with. Alright, so let's go ahead and before we actually move on to the board, we want to make sure we have a design. Now this is as simple as can be. This is going to be a very crash course video here. So we have a simple design. It's not electrically protocolized, but this is what we want to move over to the board. So we don't have connections and we don't have any standard diagrams or symbols, but it's enough for this little project. So I looked at the pinout, and this is what it looked like. For the regulator that we're using, not this one, this is a 7805, we're using an LM1117, which has a different pinout. So we want to make sure that you have your diagram on paper first. So before you move on to the board, I actually breadboarded this. And here's the in on the left, 5 volts. We're going to be feeding it in through one cap, through the LM, and then out the other cap to our multimeter. So I've got my multimeter leads right here, and let me move some stuff around to make sure these leads reach all the way. And we're going to go ahead and take a look at multimeter functions. Alright, so this is an AC meter, but it also has some DC. So voltage, ohms for testing resistors, and it's got some other features. Sometimes you can just test a resistor with the multimeter instead of having to look up the color bands. It's much easier. And then there's the continuity. Oh, not this one, sorry, this is the continuity down here. To make sure that a connection has been, electrical connection has been successfully made. So let's switch it over to voltage, and we've got the squiggly line over here, which is AC, so we switch it over to DC. And we notice that it is measuring different range, so we want to get it into the middle spot right there where we are measuring volts. So we can get whole volts on the left and decimals on the right. Okay, so we plug in our leads just like so. Black is ground, and you gotta wiggle it in there. Okay, perfect. And now the VCC. Now remember, we're going to be reading what this LM1117 is going to put out. And we're going to be feeding it 5 volts, which is what our diagram says. And it is what the LM1117 is supposed to do. So let me flip this over actually. There we go. So we're going to be receiving 5 volts in on the top notch of the LM1117 right here. Voltage in, V in. That's this cable right here with 5 volts. And then ground is the green cable right here. And now we notice that there is one row that is empty right in between 5 volts and ground, and that is because the middle pin of the LM1117 is actually VO or V out. So in this middle row right here, we're leaving it open because it's what we're going to get out of and put it into the multimeter on this side. So this is V out in the middle, and this is supposed to be 3.3 with respect to ground, which is still this bottom pin right here. All right, so let's go ahead and actually test this. Let's get our 5 volt source right here, plug that in here, and let's see if we get 3.33, which is what we should get, and there it is, 3. Okay, so we're going to talk about long lead components first. These are the easiest ones to put through one of these perf boards. And this includes things like resistors and capacitors and even FETs, so MOSFETs and transistors, and the one we're going to be using, this regulator, are all long-legged components. Now this is really easy to put through the perf board because the leads will actually help you hold the components in place. So as you can see, these are pretty easy to just slip in here, and as I mentioned, the leads will definitely help in holding these components together so that you can solder. Remember, you're going to have to flip this board over so you can solder. So it makes a big difference. It's very helpful to have those long leads, not only to hold components into place while you solder so that they don't fall out the other side, but also because you can use leads to make connections as well. Okay, this is a very scrap project, so I'm using a lot of components that have actually been salvaged from older projects or projects that didn't work, but the components are still good. So a lot of my leads are bent. This one actually fell off while I was putting it together, and that's fine. So you're going to see a lot of improvisations, just so y'all know. All right, so that's basically what it has to look like in the end. Now these two last components, which is we're going to take power out of and we're going to put power into using header pins, one of them female and the other one male, are probably the hardest ones because when you flip this board over, those two components are the only ones that fall out because remember, they don't have these long leads. And this is great in this case for our example because they are actually in the middle. The components with the long leads are in the middle. You usually want to start out in the most crowded area of your circuit because it's where you're going to have the least amount of space as you add components later on. So it's going to get a lot harder to work in these areas if you already have components on the sides. So we want to start from the center, which is going to be the most crowded. And this is perfect because the center happens to have our long lead components. So we're going to take these leads and fold them. We're folding the capacitor leads towards the regulator leads. And we're going to do the same for the other capacitor. And that is what we're going to use to connect capacitor and regulator in this case. All right, so that seems mechanically fixed, which is perfect. And I'm going to bend the one lead on the other capacitor because remember that my other lead broke. And that's what I get for using salvage parts, but I just can't throw things. I'm not good at throwing things away. Okay, so we're ready now, and our leads are very close to each other, if not touching. And eventually we're going to use this hook wire later on to connect other things. Okay, but before we get started, let's look at soldering 101. The first tip is you can either say it's soldering or soldering. It doesn't matter. The next tip is helping hands. This is an absolute must. You need to get these, and I would recommend these big ones instead of the little ones that come with a little light and a little magnifying glass. It's just because it's a lot better. Glasses are very important. Solder will sometimes spatter when touched to the hot iron, and you don't want that stuff jumping into your eye or even on your skin. It's pretty hot stuff. So, okay, we're going to use the helping hands to hold our perf board in place. And because our components are long lead components, they will stay in the holes no matter what. Okay, so we're going to use this rosin core solder, okay, and this is good because the rosin core makes soldering a lot easier, a lot smoother. Okay, so this is what we want. Soldering tips are important because they need to be nice and clean, kind of like this one. This one has some tin on it. Always want to put some tin off after you use your tip. Alright, and this is what we're going to be doing right now. So I've highlighted in red. The first connection we're going to make, or the connections we're going to make, are basically from the ground capacitor lead to the regulator and then to the other capacitor. And the 5-volt lead to the voltage in on the regulator. So let's go ahead and put this down here and let's focus on the actual soldering process. Now there's some tricks, and please don't mind my very old and worn out tip. I promise this is the last time I'm using it. Like I said, I don't like throwing stuff away, so I'm getting as much as I can out of this tip. The first thing that you want to do is you want to solder for stability. Now these components are being held by the friction that these bent leads are experiencing on through these holes. So we want to touch the tip to the pad and the lead, heat those up. We don't want to touch the soldering wire to the soldering tip. We use the tip to heat up the pads or the component leads. And we've created the two far left and far right solder points before we do the middle one. And this is because you always want to make sure that you solder in order to make sure your components stay in place. Okay, now we're going to do the last one. Remember, we heat the pads and the leads. We don't touch the tip of the soldering iron to the soldering wire. And the reason for that is that you want to heat the pads and the leads, or the components, because you want the solder is going to stick to whatever is hot or whatever is hotter. So you want to make sure that the pad and the component lead is what's actually hot. Otherwise, the solder is just going to stick to your tip. Alright, so there we go. We've made those connections, the capacitor to the regulator and the one long lead that we did have to our regulator as well. Now, in this case, like I said, because these were salvage components, one of my capacitor's leads broke off and we're going to have to improvise for that. But what I like to do is, as soon as I finish a segment or a few segments, I bring out my multimeter and I put it on continuity testing to go ahead and make sure that there is continuity where there is supposed to be, and by the same token, where there is no continuity where there shouldn't be. So if there is, it'll beep. If there isn't, it won't beep. And that's what we're looking for. Okay, now let's talk about hook wire. There's two ways of doing this, and we'll review this in a video in a few minutes. But in this case, what we're going to do is we're going to replace the broken lead from the capacitor with some hook wire. So I've tinned the tip of the hook wire that I want to connect to the regulator. So I just basically touch both the tinned tip and the regulator lead, and I quickly heat it up, and that makes for a very weak welding point, but it's at least just what we need to hold the hook wire in place. Alright, so that was actually pretty good, pretty painless. And now I come in and I heat the pad and the hook wire in such a way that when I touch the soldering wire to it, it melts instantly. And now that I've made that soldering point for electrical connection, remember this middle one, we only did a very soft, very quick soldering point. So we want to come back here and redo that to make sure that it is mechanically strong as well as electrically reliable. Okay, so we've finished both of the connections from the regulator to the capacitors. So we've connected the regulator to the incoming capacitor and to the outgoing capacitor. We had to improvise on the lead of one of the capacitors, which is the one that broke off, and we used some hook wire. All right, great. So now we're done with that. Let's go ahead and look at this hook wire duality. So basically there's two ways, either over or under, and it really depends on your preferences and on the importance of this project. So I'm going to go over both of them and of course list their pros and cons. And as always, the pro in one is the con in the other. So we talked about a few of the more common components, the resistor, capacitors, the FETs and regulators, and they have these long leads. So they're perfect for through-hole boards because you put them through and you get these long leads that you can actually use not only to hold that into place into the pad, but also you can bend them to make connections to other components. This is not the best practice. The best practice would actually be to cut off those leads once you've soldered them on. But then these other components, like headers, they don't have these long leads that you can bend. So you need to use hook wire. So here we have a female header, which we actually will be using in this component. And these are the male ones on this older project. And basically the problem is that the leads are not long enough, they're not meant to be, to go through and that you can bend them. So one option is when both components you're connecting have long leads, is to fold both leads and connect both leads, which is what we did with the capacitors and the regulator. And you can still see the long leads of the regulator. Normally those should actually be cut instead of being used for electrical connections. But like I said, this is an improvised way of doing things, and I salvage as much as I can. So, alright, perfect. That's when both components have long leads. Now, in other occasions, you will be connecting components that don't have long leads. So, in this second option, you have this male header connection that doesn't have a long lead to connect to the resistor. You could obviously connect the long lead of the resistor to the header, and that would be enough. But then there's the third option, when you're connecting components that don't have long leads. You need to use hook wire, and there's two ways. One of them is over, and the other one is under. Now, in this case, in this old project, as you can see, the hook wire is over. So what I had to do was leave enough hook wire at the end so that we could put it through and bend it just at the right length so that it would reach the header. Now, this is mechanically much stronger when you're using the over wires because you can do that. When you put them under, it's just okay. It's not better because it is not as mechanically strong as folding or bending the actual hook wire to complete the connection. In this case, when it is under, like we did here, these wires are not mechanically strong. They are connected. It is a good electrical connection. It is a so-so electrical connection, but it is not mechanically strong. Why is it not electrically better? Well, the reason is that when you connect things in the way we do when the connection is under, you first make the connection of those components on the through-hole board, and you mechanically fix them to that hole using solder. But then when you come back and you solder the hook wire to the already soldered component on the through-hole board, it melts the already hardened solder and it melts together again with the new solder. When you mix new and old solder together, the electrical conductivity of the solder that results is not going to be as good as it would have been if it only melted once. So you end up with more solder than you usually need to, and you end up with connections that are not electrically as good as they could have been if it would have been one melt, one time. So over is definitely better, both mechanically and electrically, and under is not. But of course, the final board, when you do it under, looks much better than when you do it over, because there is less stuff up at the top. The bottom is pretty clean on the over connection, but the bottom is all bulky on the under connection. Alright, so that is basically the two options. Over or under, it's your choice. Let's get back to our project. Alright, so you want to measure the hook wire no matter if you're connecting over or under. The only difference is that if you do use the over, you're going to have to leave some extra space to make sure that that hook wire goes through the hole, bends towards your component, and reaches it so that you can make an electrical connection. So you measure out all the pieces of wire that you're going to use, and there are some tips for soldering these pieces as well. Remember, it's still going to be important to have them hook on to the components that they're going to be soldered to. And so you can make little hooks with them, and we're going to go ahead and look at both of those tricks that you can use. So the first one is when you're putting in a female header, such as we're going to use, you can tin one of the holes, not both of them. If you solder all or both holes of a component at the same time, then it makes it really hard to put it through. So we soldered, or we tinned one of the holes. Now we're going to flip this board over so that we can actually insert the female header from the bottom. And all we have to do is reheat that one hole, and because it already has solder in it, we will only heat it briefly, enough to put the component right in, and then remove the heat, which will make sure that it cools down, hardens, and that way our component will stay in place. So this is still a mechanical connection. We are not doing this for electrical reliability yet. So there it is. It melted the solder and the header pin is in all the way. There it is. Okay. Now we can complete our connections from this side of the board without worrying about the component falling through to the other side. Okay, so we are now ready to go ahead and do the other one. So when we're doing connections with these wires that we've already measured and cut, one of the things we can do is actually make hooks with the hook wire, which will actually help us hook it onto components that have already been soldered, like in this case. So I'm going to make a little hook here on one of the ends, and that's going to help me secure or fix this hook wire to one of the ends. And once I get the hook in right, we can come in with the soldering iron and complete the job. Now you got to make sure that the other end also reaches the component that you're trying to connect to, otherwise you're going to be pretty upset when you're done and you can't make that connection. So a mechanical connection for now. Hold it in place. There we go. Need a little bit more heat there. And there. Perfect. Okay. And now you fix the tip on the other end. Make sure that it is touching what you want to connect to. Alright. Now one of the things that you'll notice, again, because this is an improvised way of soldering things, is that I'm not a very good solderer in general, but I guess this can be your video of how not to solder properly. But it works. It gets things done, and as long as it's not a professional project, it's not that big a deal. The other problem that you'll notice that I have is that I shake a lot. So the helping hands really help, not only in holding components in place, but I can also sort of touch or lean on the arms themselves, and that will help me steady my pulse a little bit more. Alright, so test for continuity. Perfect. Looking good. Let's go ahead and complete the job. Now we only soldered one of the pins on that header. We don't want to do both of them until we are ready to make the final connection, and here it is. Remember, this has to go kind of across because the negative from the incoming DC needs to cross all the way to the other side to the ground of the regulator. So we're going to make another hook and make sure that it reaches, and if it doesn't, then we need to fix the angles on that. There, that should do it. Now, hook it in on this side. Yep, it'll reach now. Okay, so now we're going to hook it in, and the first solder point is to mechanically hold the lead or component, and the second one is going to be for electrical connection. Alright, there it is. Looks pretty sturdy, sort of. Okay, let's make sure that we fix that component as quickly as possible so that it doesn't fall out. And here we go. Heat the wires, not the solder. There it is. And now we finish the electrical connection. Now, when you're doing plus and negative, which is very common in power sources, you want to make sure that you make connections on opposite sides whenever you're doing plus and minus, just to be on the safe side that you don't accidentally connect your positive and your negative with spilled over solder or something else. Okay. Test for continuity. Good. Good connection. Yep. Okay. Then we're good. Let's go ahead and move over to the other side, and that's going to finish our project. So we've done these two connections. So we've got voltage in coming into the cap, both VCC and ground. Okay, so for our final connections, we're going to use double-sided tape. This is another trick, and you use it to hold components onto the board so that you can make a first mechanical soldering point and then move on to the electrical ones. So we're going to use this double-sided tape. We're going to put the male header in there, and we're going to make an L shape out of the double-sided tape. We're actually only using one side of the double-sided tape in this case, and that should be enough to hold your component in place for at least enough time for you to come in on the other side and mechanically fix the component to the board. So let's quickly go ahead and pin this down and bring in the soldering iron, and remember, heating the components. So we're heating the pad on the board, and we're heating the pin on the actual header. Heat it and then melt the solder onto it. Alright, so only one right now before we move on to the next one. Okay, so moving along here, we are tinning our tips for quick mechanical connections, and then we come back and finish the electrical connection, which basically just means that we make sure that we have a little bit of tin on the component we are connecting so that it'll make for a fast connection, and once we do that, we come and redo it and add a little bit more solder to make sure that the connection is reliable and strong. Alright, so that's pretty much it. We're done with the other side of the regulator. Always remember to tin the tip of your soldering iron, no matter how bad it already is. And we're done. So let's go ahead and bring in the continuity tester to make sure that we have a good electrical connection. And there it is. Alright, good connection right there. That's good enough. Yep. And let's test the other one. Yep. Alright, so that's it. Let's just test it out with the 5 volts incoming, and there it is, 3.3 volts. Alright, so we learned how to make a power supply using a 3.3 LM1117 regulator, and we learned some soldering tips along the way. So I hope you enjoyed the video, and we'll see you in future videos. Don't forget to like, share, and subscribe. Thanks.